Hello friends, now let us see the atomic properties and the variation of these atomic properties in the groups and periods of modern periodic table. Out of these properties, let us say about electron affinity. This is the amount of energy released by an atom by taking one electron into it. Definitionally, to say the amount of energy released when an electron is given to neutral isolated gaseous atom. It's quite oppositely to say initial energy. The amount of energy released by an atom while taking the electron. If you supply electrons to the atoms, if the amount of energy released by those atoms while taking that electron is called as electron affinity. As it is energy, this also is calculated in terms of electron volts. Of course, the other units also are used. Generally used units are electron volts. Now, let us consider the variation of this atomic electron affinity in the groups and periods. This is energy, we are telling as it is the energy released by the atoms while taking electrons. So here we have to consider the relation between this electron affinity and the size of the atoms. Then we can say easily how it is going to be vary in the groups and periods. The size of the atom is very smaller. From the nucleus, the outer incoming electron distance will be less, so that this nucleus can attract the electrons very easily from outside. Suppose let us consider two atoms A and B. So one electron is given for both the atoms. From the nucleus to this incoming electron, the distance is very less here, so this can attract the electron very easily towards it into its orbits. If we consider the distance between the nucleus and the incoming electron, here distance is so far, so nuclear force of attraction on that new electron will be less in case of big sized atom. So this atom can attract the electrons very easily, and immediately it can release certain amount of energy and it accepts it. And here in this case of bigger atoms, the distance between the incoming electron and the nucleus is very far, so the attraction on the incoming electron is less. It releases a little amount of energy. In this way we can relate the size and the electron affinity inversely. Electron affinity is inversely proportional to atomic size. Now in a group, if you observe the electron affinity, in a group, we know top to bottom size increases. As size increases, attracting power also decreases. If attracting power decreases, the release of energy also obviously decreases. We can say simply from top to bottom electron affinity decreases as size increasing, so it decreases. Now let us see in a period. In a period, generally the size decreases from left to right as nuclear charge increases, that we have studied already. So as size decreases, attracting power increases. As attracting power increases, they accept electrons very easily, so that they can release a large amount of energy in terms of electron affinity. So electron affinity will be increasing from left to right because size decreasing. So in a period, electron affinity increases from left to right. Electron affinity decreases in a group from top to bottom because size increasing. In a period from left to right, electron affinity increases as size decreasing. And to say for the noble gases or for last column elements, 8th group elements, electron affinity value will be 0 because they won't accept any electrons. As we know, they have completely filled outermost shell. They don't have any acceptance still. So electron affinity for these elements will be 0. In generally, to say from left to right, electron affinity increases in a period from left to right, but for noble gas it will be completely 0.